Let's have a look at load share controllers. As the name implies, a load share controller forces power supplies to share the load. Some of the reasons for sharing the load among separate power supplies are redundancy. In applications like server and telecom, there is a lot of redundancy, and it includes the power supplies. Then there is light load efficiency. At lighter loads, it might improve the overall efficiency if one or more paralleled power supplies are simply shut down. Then there is the fact that a power supply's peak efficiency is usually well below its maximum rated power. For example, if we look at an efficiency curve for a 1 kilowatt power supply, the actual peak efficiency looks to be between 300 and 500 watts. If the system demands 800 watts of power, the advantage of redundant power is by enabling a second power supply, both can operate at peak efficiency. Assuming they share perfectly, and that is where load share controllers come in. What a load share controller needs to do is to force sharing. For example, a 12-volt power supply unit, or PSU, typically has a 5% tolerance. For a 12-volt rail, this means the voltage can vary between 11.4 and 12.6 volts. With two power supplies in parallel, this could mean that only one is doing all of the work to supply the load. Here is what could happen when not using a load share controller. If the power supplies both supply exactly 12 volts, and the blocking diodes have the same forward voltage drop, and the trace impedances are perfectly matched, the two supplies will share evenly. This is not likely going to happen. What is more likely going to be the case is that the two supplies are slightly mismatched, and one will be supplying more power to the load than the other. A worst-case scenario is when there is a major imbalance between the two power supplies. In this case, one might be doing all of the work. How does a load share controller force sharing? To force sharing, shunt resistors can be used to monitor the current for each power supply. The goal of the load share controller is to make these currents match. To make the currents match, one of the power supplies needs to be adjusted. But which one? Actually, any load share controller can become the leader and force the others to follow. The leader will assert itself with a common load share bus that links all of the controllers together. With load share controllers, the leader is chosen by the supply producing the most current. It asks the others to try to keep up. This is a practical application of leading by example. Let's look at the different parts of the load share controller. First, there is the load share controller itself. Then the power supply has to have a remote sense capability. This allows the power supply unit or PSU to regulate directly at the point of load. The benefit of remote sense for any power supply is that it overcomes voltage drops that occur in connectors, traces, and wires. A shunt resistor is required to be able to monitor the load current. And finally, there has to be a way to set the maximum adjustment for the power supply's feedback. Lower resistor values may be more susceptible to noise, while higher values will increase power losses. Well, thank you for watching. I hope you found this informative. To see more, please like and subscribe.